And I think you'll start my presentation.
Yes.
This
Today?
Yes.
Yes.
Welcome to this presentation with title By Hand and by Computer. My name is Jonte Bernhard and my co-authors are Jakob Davidsen and Thomas Ryberg. As the subtitle tells, we have done a video ethnographic study of engineering students' representational practices in a design project. We have looked on the fifth semester students in the PBL-based architecture and design program at Aalborg University, and the students are designing a real office building in groups of 5 to 6 students. And we have followed several groups with multiple video cameras over several sessions. In this episode, we see that Ina and Mette are going to discuss a design decision. Ina has been troubled by something, first by looking on her iPad, and then she looks on a paper drawing, and then she calls Mette's attention to discuss. Mette comes over to Ina and she points to a feature in a styrofoam model to explain. So the students here using iPad drawing, styrofoam model and fingers as resources. To further explain, Mette make a gesture in relation to the styrofoam models, and she continues by taking another piece of a styrofoam model, another floor, to explain. So here we're using styrofoam models and hands as resources. To finalize their decision, they go back to Mette's computer to look at a 3D CAD drawing. And actually in that drawing, Ina is walking around with her fingers as representing like a person. And then Ina make reference also to a photograph which are on a board as an inspiration to just underline their decision. So here we had using 3D CAD, fingers, and photo as resources. To sum up, our results and conclusion are that we can in our data see that the students are using a wealth of bodily material sources, and we're using it in a very integral and seamless way. It's our gestures, we have concrete materials like the 3D styrofoam model, we have more what we can call low-tech sketches, drawings on papers, we have high-tech iPad and 3D CAD drawings. But our results, as we're using it very seamlessly, a challenge that you should see by hand and by computer, or analog and digital as opposites. Rather, we are using it very seamlessly, so our results imply that actual students should be trained to work both by hand and by computer, and it points to a what we could call a post-digital perspective. We much talk today about digitalization, but digital should not replace our tools. The digital should make up a part of an integrated totality with other tools. So thank you for listening, and for more details, please discuss with us or read our paper.
Now I'm not muted. So thank you, Jonte. Now we move to our second presentation by Ron and Bart, entitled Design-Based Research, Students Building Workplace Skills in a New Educational Model. Yes.
Thank you, Ida, and welcome everyone. It's good morning here in the United States. I'm here with my colleague Bart Johnson, and we have a paper using design-based research to study the workplace skills that students build in our co-op-centric model. The co-op-centric model does have a great collaborative design aspect to it. Design-based research, maybe you're familiar with it, not certain. There are really two cycles going on. One is a research cycle where you get a research question, data acquisition, analysis, and the results of the research feed into the engineering design process of something that's being designed. And in our case, what we're designing is a program, a new program. And as the program evolves, questions come up to feed into the research cycle. So it's very integrated. It's a form of action research. And we're looking at workplace skills. Here is a quick description of our new program. It is a 4-year Bachelor's of Science in Engineering. The first 2 years happen at a community college anywhere in the United States. Students do their calculus and physics and pre-engineering courses. Then they come to the Bell program for 5 semesters. And the first part of that is this Bell Academy, where they really build their collaborative skills, they build their workplace skills, so that they can then go and do 2 years of paid internships, co-ops, while they're continuing to acquire their technical, professional, and design knowledge. And then at the end, they get their bachelor's degree. On to you, Bart.
Well, welcome as well, everyone. Thanks, Ron. As Ron talked about our design-based research approach, this really is part of a longitudinal implementation. We're in our 4th year. The developments have been using DBR to really help design and guide and give us feedback on the development. In fact, we presented at IRSPBL last year on another aspect of the DBR development. Specifically, in this study, we are looking at the learning activity alignment. As students are in this co-op and workplace-centric learning model, we wanted to start to see what learning activities were they aligning their learning with and that they identified. And we also really wanted to see what were the skills that they were identifying were critical to them as they're going into this workplace-centric learning model. And our findings in brief, really just focusing here in the presentation on the skills identified by the students. With our word cloud here, you can see that time management stood out strongly to the students as a skill that they were acquiring and needed in this work-centric learning model. And really the aspects of job searching, because they had to find their own co-op intern and internship opportunities for this learning model, the design work, and you can see presenting, writing, the use of modern tool. We're proud to see that safety showed up there as something important for the students, and data analysis. So a lot of those critical skills that we would hope students would identify as critical to their jobs as engineers in the workplace, they are identifying those through our studies so far. And with that, our research or our question to the group here for discussion is certainly what role does this co-op centric learning model have in the future of PBL and engineering education? It's new here in the US. There's not a lot of models similar to it. And so our curiosity is your opinion on that role in the future. So thanks.
Yes, thank you. And now we move to our last presenter, Preti, with the topic, with a presentation, Assessment of Collaborative Problem-Solving Competency in Engineering Education, a Systematic Literature Review.
Hello, I am Preeti Baligar, PhD student in Engineering Education and the author presenting the study. In this article, we discuss the theme of collaborative problem-solving competency and what is needed to develop it using design problems in engineering education. The competency of collaborative problem solving consists of both cognitive and social aspects. Many current studies have assessed this competency for online collaborative problem solving tasks. One such study is by PISA, Program for International Student Assessment by the Organization for Economic Cooperation and Development. The participants were school-level students and the context was non-engineering. These studies identified the overt indicators of the competency. However, in engineering education, when students solve problems in a face-to-face mode, there are two challenges. What knowledge and skills can serve as overt indicators, especially in collaborative in-person problem-solving tasks, and how do we design such tasks? Our study uses the methodological recommendations of systematic literature review to identify what has been done previously to address these challenges. This study summarizes that to design learning experiences for collaborative problem solving in engineering education, we need to understand the characteristics of collaborative tasks and apply them to create tasks in engineering education. Explore the principles of task design, that is, evidence-based design, and apply them to design tasks that develop both social and cognitive skills. Finally, we propose the need for a progressive ramp of these competencies across the 4 years. We hope that this paper opens up new avenues for research. Although this SLR focuses on design problems and its competencies, the findings of the study open up opportunities for further research in the other type of complex problems which engineering professionals solve at their workplaces, like troubleshooting problems, system analysis problems, and decision-making problems. Project-based learning has been exhaustively applied for design problems. We propose that there is a need to create successful applications of PBL for developing collaborative problem-solving competency for system analysis problems, decision-making problems, and troubleshooting problems. Additionally, we also need to identify what mechanisms exist to overtly assess both social and cognitive aspects. Lastly, this has special implications at first-year undergraduate engineering because this may be their first intensive team-based engineering problem-solving experience. With this, I come to the end of my presentation. I thank Team IRSPBL for this opportunity. Wishing you all the best.
Yes, thank you. Even though the papers touch upon, well, specifically on different aspects, I think they kind of complement each other. For example, with Jonte and Jakob and Thomas' paper, we could see actually the focus on, in a collaborative learning environment, what tools do they use to design in a design process, but it's also about the decision-making process as well. And this is also a collaborative task. On Ron and Bart's presentation, we're looking to actually design, but another type of design is using as the design-based research as cycles of learning and how developing this job-related skills, including decision-making, problem-solving, but also how to manage the time in their collaboration. And I think this is very interesting of this concept of co-op centric learning, and we can talk a little bit more about that ahead. And then we're looking to pretty
conference
paper, and then we actually see the systematic literature review and this follow-up questions that we can say, well, if we look into Jonte and co-authors' papers, then we might actually have specific aspects that we can look into and see how can this be translated, or how can this be actually impacted the collaborative and problem-solving skills development and so on. So I think this is actually very, very, very interesting how these three papers come together. We have one question already in the chat from Pretty. I think I will copy and paste it for everyone. And it's addressed more specifically to Jonte, but I would like also the other authors to give their comments. how can we use the findings of this ethnographic study to redesign collaborative workspaces?
Oh, how we should redesign. I will say that we should, even with designing college, we should look very carefully into how students or actually professionals really work, not taking theory and ideology into their design. As we didn't mention actually in the paper, but we have seen when we watch through the videos that the students actually, we're talking about, it's not an dichotomy, but working collaboratively and individually. We can see the students were working sometimes 2 and 2, as you saw in the episode. We sometimes see them working in as a whole group, or groups of 4, or groups of 3, or individually. So I think you have to take that into account when doing further design on collaboration, and also had taken account all this multitude of tools which the students were using both by hand and by computer. I don't know if Thomas or Jakob will add something to my answer.
Yes, Thomas, please.
Yeah, thank you very much for that very good answer, Yonde. I think one thing in addition is also the unique thing about this is also that students are participant directed. It's a lot of responsibilities for them to actually design their collaborative workspaces. And they're seated, we can't see that in the video, but they're seated next to other groups. And what is also interesting is how they inspire each other, and you can see certain practices travel among the group. So certain ways of doing things and structuring things are adopted by others. And of course, they also learn by professional practitioners how to develop a design studio. But I think also an important point is that they get to decide it, or have to decide it.
Yes, anyone would like to comment or follow up? Yes, Ron?
I find your paper very interesting, and I really like the idea about both, the post-digital working by hand, and in this new COVID world for collaborative workspaces with our students, we ensured that they all had both an iPad and an Apple Pencil, and we encouraged them that they're still doing work by hand, but it is on a digital platform that can be shared more easily through Zoom meetings, etc.
Yes. Preeti, do you like to follow up, or anyone would like to comment?
Oh, thank you. I think I'll go through the entire paper once to understand what they have done in their findings, and maybe email the authors accordingly.
Yeah, I actually have a question, especially on this. I think it's very interesting, this balance or this use on in hand or by hand, and then the digital in the design process. And my question is that first, if you can see a progression on first prioritizing by hand, and then as you move to the final product, you also move more towards digital, or if it is something that they learn from each other and there's no relation whatsoever. If you observe some sort of progression in this change in relation to the decision process and the problem and project timeline?
I'm not sure. I'm not following the full project timeline, but we can see when they are making our discussion, when just by doing sketches is much more flexible. When a 3D CAD drawing is much more, you have to, it's more for documenting final decision. But also you can see, we could see that all these tools has different affordances. The 3D draw, they could rotate, but we could also rotate the styrofoam models and look from different angles. And like all these photographs, or many things are as documentation of earlier ideas they have, and we are revising ideas. We had to manage some conflicting constraints, or as you always has to do in a engineering design. So it's but there are some. I think we should be very careful saying that it's a progression to be able to handle computers. We have different affordances, but we are using the final drawings are fine. There are documentation and then.
Yes, Jakob.
Just to follow up on Jonte's comment, we also see examples in the material where the students, they are moving from 3D models that they developed in a 3D programming environment, and then they move towards developing and building the materials in a physical building. And in that transition from the fixed digital model, they move to a tangible model. And in that transition, in one of the episodes, they actually experienced that what they originally thought was perfect in the 3D world was not perfect when they tried to assemble the model with the physical and tangible materials. So it's not to say that they move from physical and tangible materials to digital, but it's also the opposite direction.
Yeah.
So I think it's
an important point.
Yeah.
That's interesting because it's different realizations basically. Because what I see in the first year students in engineering, they have a preference on handwork when in the beginning to generate actually ideas or sketching, because it's much more easy. It's something they are used to using by hand, and then moving towards the final product, moving towards a more digital or more, because it's more shaped, it's more, the decisions has been made along the process. So it's kind of, they converge somehow from a divergent thinking to a more convergent thinking. And I've seen that in the first year students, especially on mediology students. And that's why I asked, but then there's another transition. And that's interesting because it's another level of work, I would say, and also thinking.
I think you have like it's converging and it's diverging when we become even more professional.
Yeah, I think it's very interesting. Ron asked about the analysis of the 500 hours of video. Would you like to elaborate on that? I think it's a very interesting point.
As Thomas already have written, made some choices. Otherwise, if somebody, I don't believe in slavery, except when it comes to transcription of videos. So.
But you had some prior criteria to say, okay, or it was just more free.
For this study, we looked into, especially on episodes that we could see much tool use and such. For some of the analysis, maybe we'll look into more on where collaboration, how collaboration are changing. So you have to have a focus depending on your interest or your research questions.
Now we have a question from Bart as follow-up. How did you choose which activities to record?
Now, they recorded all 6-hour sessions, or actually Jakob did it, and it follows such. So for first, we recorded group activities, and then we had chosen to analyze the preparation for the day before the status seminar. Unfortunately, the students didn't get agreement from the students to record the status seminar, but in later recordings, I understood from Jakob that we have got such agreements. Jakob can maybe comment on that.
Yes, I'm not. The question is really, how do you end up with that large amount of video? And I wouldn't recommend anyone doing that because it's really like a constant bad feeling that you're not looking into all the video. But it was part of a larger setup where we followed students in architecture and design education for 2 semesters, and then I have returned to follow how they developed their professional skills at the first semester. So now we have recordings of how they prepare for a status seminar or a crit session, as they call it in architecture, on the first semester. So to see the progression in how they develop competences in preparing for like participating in crit seminars, which can be really I was about to say hostile environment, but that's perhaps a bit of an exaggeration. But it can be really a tough climate where you will present your work and you will get critique. So we found that as an interesting point of departure to understand how they develop professional collaborative skills.
Yeah. I think you have a very rich now data set for the years to come. Yeah. I would suggest we move a little bit also for the others presentations,
Yeah.
and if there are any questions for Ron and Bart or Pretty, and I invite Oscar and Rosella to bring forward their questions and also intervene in the discussion. And you can raise your hand. You don't need to write. You can raise your hand. So yeah, and we have a question.
Yes.
Yes,
Yes.
Pretty. Yes.
This is for the authors of paper 2. I actually found their work very interesting because at KLE Tech, at my institute, we have an option where students can intern either at startup industries or at mature industries. But I never really got out to study how the skills developed by these students in these 2 types of industries vary. So I'm really interested to know what the authors think about it. Do you think the skills developed while interning in either startups or mature industries vary? What do you think is my question.
I think that they do vary quite a bit. But what we're trying to do in 2 full years is get our students a variety of those different kinds of experiences so that they can develop maybe the more entrepreneurial skills versus more of the risk management skills. The whole point behind our model is that when a student graduates with her engineering degree, she's got all of these experiences to draw back on to put into play as a new engineer. And some of them will come from a very mature industry. Some of them could come from a very, brand new industry. But the set of skills, the collaborative working skills, are very similar. You still have to be able to work on a team. You still have to have, you have to be inclusive, and you have to be able to communicate well. So there are some nuances that would come from the 2 different scenarios, but the skills that we help them focus on really are the same set of skills. I see Tomas's question here. Bart, do you want to grab that one?
Yeah, and I was going to add to it, and I think it kind of helps with the co-op model question too, is a student can go on a co-op or internship and learn very little too. It depends upon how intentional the student is to connect, that workplace learning experience with their academic experience, and how intentional the connecting of that learning is. So I think one thing that we're doing in our co-op model, students aren't just going on these co-ops and then coming back. The learning model for the program is premised on preparing and building them for this co-op. They're attaining the co-op, but as they're attaining the co-op, whether it's an entrepreneurial startup company or a mature one, they're looking for skill set development when they go to that company. So that intentionality really adds there. And I think it's, when we talk about this being centric to the learning, it is preparing that student to be intentional for that skill development and understand the skill that they are developing and helping to coach them. And so the co-op model, the intent there to more answer that is, students are brought in and we have them physically at our, well, with COVID, of course, the world has changed, but in a non-COVID world, they're physically coming to our institution from places all around the United States and are going through learning workshops, courses to prepare them to go back out into the workforce come the spring semester time frame. And then they keep connecting, we keep connecting with them via technologies like Zoom and having them return to our institution. But the model is that they're primarily out in the workforce from that point forward, but we're very intentional with connecting their learning back to the work at the institution in their third and fourth year of university.
I'll add on to that just a little bit. For those 24 months that they're on their co-op, they work about 40 hours a week. And then in addition to that, they have about 10 to 12 hours per week of assignments they are completing for us. And those assignments can be a technical course. They might be taking an advanced heat transfer for half of that 10 to 12 hours per week. The other half is where it really, the power of the model really comes through. It's reflective writing. So we give them learning journal prompts to really dive into and analyze the professional situations they're going through in their co-op, the design experiences they're going through in their co-op, and then all of these skills that we're looking to have them develop, we're having them put the microscope on that, analyze it, and then one of our professors does meet with them, as Bart just said, to discuss those reflections.
May I ask a question orally? Do you see in this co-op, or you say like we are reading a course on heat transfer or something, do they during the co-op, do you see an improved skill in relating, like engineering theory, to what they are actually doing? Or because that you can see very crucial in, you can see how much engineering education research has shown that many students have a difficulty in connecting theories to the real world, or whatever we call it.
Absolutely, and that's what we try and actually get them to pair the course that they're going to take with the work they're doing. Because when that happens, their motivation goes up. Their motivation to acquire advanced heat transfer goes up when they know that they're going to work tomorrow and are going to be applying it. But the contextualization of that learning is what really is going to make it last, because it becomes a part of their lived experience when they are applying the principles, applying the knowledge to an actual design, to troubleshooting an actual system. And that's really the intent of the program. Now they take, in those 24 months, they take 24 different technical competences, and we can't align them all, but we figure the more of them that get aligned with the actual work they're doing at that time, the more valuable that experience is. And their reflections are showing that. So we're 2 years into this now, and we are seeing the results of that intent.
That's good, because what you want to avoid is like, people just tinkering, and but it's with theory, it's not only that you're able to apply theory, you should also be able to know which theory you should apply.
Exactly.
Yeah, I think I'd add to it too. You know, I know students respect us as faculty when we're instructors in their courses, but at least for us, many of our students, there's then the real world and engineers, and when they're seeing the practice of thermodynamic theories being utilized actually in the workforce, and in the real world, as we'd say here sometimes in the United States, it adds so much of a reinforcement to the students on how valuable that theory really is. It's just not homework or labs that we're having them do. It's got a real practical application, and what it differs an engineer from, say, a technician or a designer for us in our industries is the ability to bring that theory in. So there's a real richness that the workplace co-op centric piece brings when they can see that theory being utilized there in the design or testing process.
I think you answer your own question. What role does co-op centric learning can do or can put forward for the PBL, the future of PBL? I think you answered also. You actually mentioned, contextual learning and the meaning, actually learning gets a deeper meaning when it's contextual. And we have so many challenges now, like sustainability or even now issues that engineers have to deal they are quite abstract sometimes and hard to grasp. So bringing it to a more concrete understanding through context, by understanding context, and then make this leap again, maybe for the abstraction. So yes.
Thank you, Ida. Before we move on to the third paper, I just do want to do
Yes.
a shout out about our model. The Iron Range model is more than 10 years old, and it was inspired and adapted from the Aalborg PBL model. But the new Bell model takes a lot of that, what came from Iron Range, and we were inspired and adapted the Charles Sturt model in Australia that you and Lindsay and Jim Morgan have. So it really is a combination of the Aalborg and the Charles Sturt coming together for the development of this new program. So just a shout out to Aalborg and Charles Sturt.
And actually, I was going just to add one thing in terms of future, is that if we look into this, what would be the next step? How this could actually make the curriculum more personalized or more flexible. And also, we are talking a lot, there's a lot of conversations and talks about lifelong learning and, upskilling and reskilling. Also, how can this model play a role in that? Because I think that's what also the future points to. So it's actually basically more or less when you refer to the Charles Sturt in Australia, that we can also look into this flexibilization they also have and individual learning paths. Yes. So then I would just we would move to Preeti paper, and Ron actually has a question for you, Preeti. It's in the chat.
Yes.
Yes.
Let me do. Okay, the question is, could you give an example of system analysis or decision-making problems? Yes. We have a first-year course called as Engineering Exploration, in which one of the pedagogy that we use is reverse engineering to teach design problem solving. So in it, we gave them a system of a gear train. And with that gear train, which had a number of gears in it and a number of interacting and interconnected parts. And then we told them, take this gear train, pull up all the components, rip apart the system, and tell me which are the various subsystems in this, which are the various components in this. How are these components connected to each other? So they laid this all out on a table, and then they told us that, all right, this is what the system is all about. And with this, we introduced them to engineering design, wherein we said engineering design is all about designing components, subsystems, and systems. So we rooted their example in this particular activity. So this is what we did. Another decision-making problem that we generally use is during concept generation. We have a design experience spanning an entire semester. So in it, the students go from all the way from problem definition till physical prototyping. So decision-making was one of the problems wherein we gave them 4 concepts, and we asked them, can you please evaluate these 4 concepts with respect to certain criteria? It is a good old bug chart. And the decisions that they arrived at, this particular concept is better over concept 4 because of these reasons. So these are the examples of system analysis or decision-making problems. But this is what we have contextualized at first year. I would like to see how we can take this further across the 4 semesters, across the 4 years. So did I answer your question? Thank you.
I actually have a follow-up, and it's about
yes.
thinking in systems. And you refer now to actually first-year students. What I found
yes.
here that students normally, correct me if I'm wrong, but they come with a quite linear thinking.
Yes.
So they have some sort of difficulties to actually see a system as a whole, to see the interdependencies, to see actually the connections, the influences. And I see, for example, that it's not a technical system, it's a social system, but with the project management. It's very hard for them to actually see how motivation is a component, how conflict is a component, how communication is a component, and this just in the part of the collaboration, and how if one does not go, or if they do not take care of one element, it can affect the others, actually.
Yes.
And it's very difficult for actually students to think in terms of this thinking. My question is actually, do you experience these challenges of actually students perceiving the system as a whole and how they actually verbalize that? What are the main challenges you encounter?
Yes. Again, I have to root this answer in my course, the first year projects and the mechatronic prototypes that they design at the end of one semester. Now, as we take students from the problem definition to concept generation, we follow a very divergent thinking. And this is where we tell them that, listen, you are trying to solve a problem soon after I posed you a need statement. That's not the way it works. You have to go through a process of a systematic information gathering, and then maybe you go ahead. We actually structure this experience at first year. But we have been trying this for almost 5 years now, and this is what we've understood. When it comes to this kind of a thinking, the convergent to divergent and then convergent thinking, for first year students, let us try and structure it to some extent and make them think in maybe not a silo, but in a bigger boundaries. So yes, we've been trying this out and we've been fairly successful in doing it.
That's very good. We start that with what we call the problem analysis, actually, to map the different dimensions of the problem and gathering also the information. And sometimes they have to actually talk with people. And that's a little bit complicated as well. And that's why I'm asking. We are approaching the end, but I have just one actually question. And this can actually be open for everyone. It's on these challenges that we see, but also the synergies that we see, and we had challenges brought up by Jonte, and the synergies, and also these intentions where students link academic experience with work experiences and everything, and now Kitty with the systems analysis and decision making. So my question is actually how collaboration and peer learning support on developing this synergies, but also addressing these challenges.
Well, I would address the social nature of learning in and of itself. The fact that my shared learned experiences with others becomes a fabric or a network of my entire learning. And without that collaborative shared experiences, my learning experience is quite narrow. But as the collaborative aspects of it and the social development and social construction of it, it takes my narrow perspective, my narrow experience, and really broadens it. I like to think of a spider web analogy.
Yes. Any more comments, Betty?
Yes. I understand that your question is about how do we orchestrate students to collaborate. So So I've been doing a lot of research in this myself, and I realized that it is the intention to collaborate which is of primary importance. Because during collaboration, there are two kinds of communication. There is some task-related communication, and there is some communication to understand what individuals intend to do. So if the transactional cost is much more than the task work, then I think students will just tune out, because the transactional cost of understanding what the problem is an overhead. So yes, this is what it is. The tasks has to be designed such that there is some sort of a balance between how much an individual can do and how much a team can do. So we've been trying to emphasize that as an individual, you can't really solve a design problem in 12 weeks' time. Go ahead and try it. If you fail, come back to us. It's okay. So yes, we let them fail a bit and then come back to us and say, hey, listen, I need a team.
That's really a good point. Get me a team.
How do you teach them to swim? I'd like to know.
I'm sorry.
It's that when we actually at Aalborg we have a saying that we just throw them to the deep water, and then they have to learn to swim, and that's what Thomas referred to. Am I right? We throw them to deep water. Yes. Any last comment? Or no. So I think I'll make the closing remarks and thank you very, very much. This is very, very, it has been very interesting, this discussion. We talked about the collaborative, we talk about the different experiences, and we talk about the different modules and practices that you actually brought with your paper, and also knowledge. And we kind of unfold relations among also other aspects like contextual learning, for example, or decision-making process, or these challenges, synergies, this intentional learning, these transactions also that there need negotiation in the groups. And so we touch upon a little bit about everything. And I think this is also, it relates very well with the theme about the PBL, the social and the cognition. So thank you very much for your participation and your engagement in your discussion. And I call your attention now for this last slide about the PBL Week 2021, a call for papers. And we are working on that. And deadline abstract 5th of December for both, for the PBL 2021 and for the IRSPBL 2021. Yes, so thank you very much. I wish you a very good night. Ron and Bart, a very good day, and for us, the rest of the afternoon. Thank you, and
thank you, Ida.
Stay safe.
And
stay safe. Stay safe, yes. Bye.
Bye.
Bye.